Hello and welcome everyone. Our today's question is very interesting and it is based on prime numbers. So what the question says? We have a number n. We have to find two pairs whose summation is equal to n, and those two numbers must be a prime number. So 3 and 7 summation is equal to 10 and 3 and 7 is a prime number. Suppose we have a 3. So if the answer is not found, we have to return -1 and -1. So this question is based on prime numbers, and the algorithm which we will discuss is called as sieve of erratocenes. So this is a very powerful and fast algorithm. So let's take any random value. So I am taking 16. So in this sieve of erratocenes algorithm, we have an array. So we have this array of n plus 1 size. So we have 16 size array, and every element is a boolean, and each and every value by default is true. So as we know, first 0 is not a prime number and 1 is not a prime number. So we will mark 0 and 1 as false, and we will start our algorithm from 2 onwards. So from starting from 2, as you can see, if 2 is a prime number, if any value is a prime number, so its factor 4, 6, 8, 10, 12 is a non-prime number. What is a non-prime number? So in this non-prime number, we have factor one more except from 1 and this current value. So 4 factor is 1, 2 and 4. So we have an extra value. So 4, 6, 8, 10, 12 is not a prime number because we have its factor as 2 also. So if we have 2, if we have any value as prime number, so we will mark its multiples with false because its multiple is a non-prime number. So if 2 is a prime number, so I will mark 4, 6, 8, 10, 12, 14, 16 as false. So this value is false, is a non-prime number. So we have tackled two factors, 4, 6, 8, 10, 12, etc. And we have next number as 3. As we can see, 3 is marked as prime number. So 3 is a prime number. So 3 factor is 6, 9, 12, then 15, etc. is a non-prime number. So 3 factor is 6, 6 is already marked as false, then 9, then 12, then 15 is false. So 6 and 15 I will mark it as false. Then next number is 4. 4 is already marked as a non-prime number. So nothing to worry about. Then we have 5. So 5 factor is a non-prime number. So 5 factor is already marked. So we can run a loop, but that will not affect our array because 5 factor is 10 and 15 is already false. Then we have 6. So 6 factor, 6 is already false. So no need to worry. Then we have 7 as prime number. So as you can see, we are traversing only in the prime numbers. Then we have 7. So 7 factor is 14. So only 14. So range is 16 only. Then we have 8, 10, 10, then 11. 11 factor, 11 is a prime number, but 11 factors is 22. Then we have 33. Then we have 44, but range is till 16 only. Then we have 13. 13 as a prime number. So 13 multiple is 26, etc. So we have to start a loop from 2. Start from 2 till n. And inside that, if any value is a prime number, So prime, if ith number is a prime number, then its factors. What do you mean by factor? Factor means 2 cross I till n. Just mark it as false. So it is a jth loop. So jth loop, mark it as false. So that's all. It's if, then for loop. So we have closed the loop. You can optimize this loop also. How? So let's discuss it. So in this, I'm starting from 2, 2, 4, then 6, then 8, then 10, then 12, 14, then 16, and then we have 3. So 3 will go to 6, but as you can see, 6 is already marked. Then we have 9, then we have 12. As you can see, 6 is already marked. So why not start from 9 onwards? Instead of starting from 2 cross I, if we start from I cross I, so like here also, from 5 we have to go to 10, then we have go to 15, but 10 is already marked by 2. So why not go directly to 25? So I'm saying, instead of starting from I cross I, if we start from I cross I, this will optimize our for loop. So that's here. But one more thing, if we have a loop till 9, so here we have a number as 16, and we have gone till 13, but the last value which we encountered is, so we have encountered 2, 3, then 5, 5, 10, then 15. So 5 also, then 7. 7 will go to 14, and then we have 11. But 11 is unnecessary because 11 factors is not there. So instead of going till n, instead of going till l, if we can optimize this, so if we have a number as 3, the maximum factor we can encounter is 3. So if we have a number as 25, the maximum factor is 5 only. So we can optimize this by, so instead of going till n, I'm starting from I is equal to 2, and I have to, if we write it like this, I cross I is equal to n. So what will this do? So we have a number I cross I is equal to n. So it is equal to, I is equal to under root of n. So 25 under root is 5. So the maximum number we have to go till 5. So 5 is the maximum number. So that's here we have to write it like this. So this will optimize our loop also. So that's all. This is called sieve of Eratosthenes algorithm. And after traversing this, we have filled our prime array by false and true. So we are only interested in true values. So let's take a list and fill our true values. So I am making a list, and the list value contains 2, 3, 5, 7, then 11, and then 13. And we have to find n is equal to 16. We have to find two values. So we can apply binary search here. If we uh, take a variable I on the 0th index and j on the last index. So let's take the summation. Summation is 15. So 15 is less than our number, target number. So if it is a less number, so we have to increment our number. So we will increment our I number. So what is this? This is 16. So 16 is equal to 16. So we will return 3 and 13. So that's all. If it is a suppose it is a greater number. So 3 and 13 here it is equal, but let's suppose it is greater. So let's suppose we have 14. So 16 is greater than 14. So we have to decrement our number. So we will decrement our JS pointer. So that's all. So let's get back into the code. So first we have primary sieve of erratocenes. So here sieve of erratocenes we have primary, and by default the value is true. So mark 0 and 1 value as false starting from 2 onwards. If it is a prime number, then its factor is a non-prime number. So false. Then we have to return prime number. Then we have to create a list. Create list here prime length. If it is a prime number, add into your list. Then create two pointers L and R. We have a answer list. We have to return. So L is less than equal to R. We have two values A and B. If its summation is equal to N, just return the values. If its summation is less than, we have to increment our value, else we have to decrement our value. If no value is found, we have to return -1 and -1. So it's time for time and space complexity. So we have this array sieve of erratocenes. Sieve of erratocenes. This algorithm takes order of n log inside log n. So this is our algorithm, and after that we have a create list. Create list will take of n. Then we have this array, so it will take log n. So if you want to read about the sieve of erratocenes, here is the article sieve of erratocenes on the Geeks for Geeks. I will link this article in the description. So the problem is solved now. If you have any doubt, feel free to ask in the comment section. Thank you all for watching this video.